Okay, it's the top of the hour. Let's get started. This interim, the purpose for today is to let Lawrence keep moving forwards on the document. We are working on trying to find working group consensus on all parts. Different parts are being opened as in where there are new topics, and so Lawrence will talk about that with some of the open issues, and especially the main part of this is talking about tags 2 and 3 and where they fit in specifically for this document. Just as a reminder, we are working in the with the IETF rules, and most of this work is supposed to be being done on the mailing list. Lawrence asked for this meeting so that we could do some more high bandwidth discussion. My preference is strongly to actually have high bandwidth discussion on the mailing list. Because especially when we're talking about things where what is a data model versus what is a serialization versus a what is, verbally we don't all do so well, and trying to report back to the mailing list afterwards is a little bit difficult. Let's see if this works. So Carson, you already have your hand up?
Yeah, before we start with the serialization thing, just a quick report on the CBOR Pact.
Nope, please, Carson, please stop. That's not appropriate for this call. If you've got reports like that, please bring them to the list.
Okay, it's not a technical report.
The list is not just for technical discussion. The list is for finding ways of moving forwards to get consensus on working group documents.
Okay, so I'll send a message to the list. Thank you.
Thank you. Okay, given that, Lawrence, why don't you just take it away?
Okay, do I have slide control?
Oh, I am too much of a novice to remember how to give you slide control. Do I, wait, do I hover over? Carson, can you walk me through this verbally? Wait, I got it. Thank God for tooltips. I am no longer controlling the slides, it tells me. Therefore, I certainly hope it is Lawrence.
Yep. All right. So the first part here, I've got 3 slides on the status of the draft. And then a discussion on the tags 2 and 3. Hopefully I get through the status in about 10 minutes. It's not for any discussion on the issues. It's just to have everybody know what's going on, and particularly a little bit know that there's some action items on some people besides me. So since the 01 draft, there's 3 minor PRs were merged into in GitHub. The reference to the CBOR, new contributor, and small clarification. So nothing worth publishing an 02 draft. Then here's the list of 16 open issues. The ones that are marked to do are things where someone needs to do some serious writing work. They're really not up for discussion right now until that writing work is done. So I'll go through them from the top here. So one was a subsection, a new subsection on when to use general serialization. That has an open PR. So the writing is done on that. It's open for comment. There is the next one is a section for general recommendations. I'll catch that when I talk about PRs. Then I have as open issues things like get consensus on things. So we are kind of tracking in the GitHub issues what work is to be done. So that's consensus on tags 2 and 3 equivalents. That's our open issue today. We we're not. I think we're not. I think not everybody's sold on the name ordinary serialization. There's some discussion on that. We need to get consensus on what we do there. Then there's a request to make some of the appendices normative. Rohan made that request. Rohan also requested additional security considerations. On this, I made the point that I don't think we're doing anything in this draft that changes the security considerations of RFC 8949. So if there's like general security considerations about CBOR that are new, I think they need to be handled in a different way. Anyways, I've pushed back and asked Rohan to take care of this. I'm not planning to do any work there. There's a couple of shoulds that related to big numbers. We need to either justify the should or turn them into musts. Then to-dos of test vectors, rename the .det control operator, need to fill in the text for tag 0 encoding. Then Rohan made a comment about shortest length encoding for byte strings. I don't support this, and Rohan thinks probably can let this one go, so it'll probably turn into a won't fix. And then there are 5 issues that Anders filed that basically I've asked him to, they're big issues, and I've asked him to create a resolution or consensus on the mailing list. GitHub is not a place for creating consensus and long discussions. It's more for tracking. So let me stop there and see if there's, let me go one more. And here's the open PRs kind of processing. So one is Rohan did a general review, and there's many comments about many parts of the document, and we're processing them, resolutions in progress. Then there's a PR for when to use general serialization. That's ready for review. And then a PR for a general recommendation section that needs more editing. This is the PR that basically says, or the text that says, you should use ordinary serialization. It's not quite that simple, but that's the main point of it. So let me go back to the list of open issues and see if there's any comments or questions. You are obviously welcome to file new issues.
Rowan, your name got mentioned a zillion times. Do you want to respond here?
I think what Lawrence said is accurate. Yeah. I mean, I think the question about the making the appendices normative, if there's no objection, then I'll go ahead and write a PR to do that. But
my preference on that one specifically is to just make them not appendices.
Yeah, exactly. That's what I was going to do, a PR to move.
Right.
Move
people reading RFCs impute a lot of context when it wasn't, there. So just having them be in the body would be lovely, if that's what the working group wants. Anything, Rowan, do you have enough time to be working on the other to-dos that you are tagged on?
I mean, I'm doing my general review. Like, I'm a little bit like pretty slow round trip time, but I made some cycles on it, and those other PRs are easy.
Okay.
So
great. If we can, again, trying to keep one of the problems as a chair in trying to get consensus is if there are long lags in between, people forget that we actually got close to agreement, in the past. So if you can get stuff done, certainly within the next week or two, show it on the list, that would be lovely. Lawrence, are you waiting? Is there anyone else who you want me to bug on this slide or the next one to get people to add in? I'm particularly interested in the test vectors ones because that's not easy, but it's super useful.
Yeah, I think that's going to be a fair bit of work. And if anybody wants to contribute to that, that would be nice.
Joe, did your hand go up at exactly the right time here?
It did. So I'm happy to help with that. Ping me when you're ready. Just send me an email one-on-one and point me at the right place and what format you want, and I'll start pumping in examples.
Okay.
Excellent, thanks. And since we do have a few libraries that do very different things, and that's one of the discussions that we're about to get into, that, is a library doing things because it's a data model? Is it doing it for serialization? Which side of the connection is on? If we need a place, once we start having test vectors, if we need a place to not only have the preliminary test vectors set up, but also library outputs and such like that, if I can run them in a VM or whatever, I'm totally happy to do that. Because again, I think that test vectors is super valuable. And again, doing this as a working group participant, not as a chair. So as we get there, people pointing me towards things, I'll set up a separate repo, probably not in GitHub. I'll use Codeberg, but where people can be getting the test vectors correct. I believe that having test vectors well established before we start working group last call on this will help focus the working group last call. So anything else, Lawrence, before you move on to 2 and 3?
Yeah, two comments. One is on the test vectors. The only thing that's really different here in this draft from RFC 8949 in relation to test vectors is NAND payloads. So most of what this draft does is clarify and restructure and rename. So
I'm not sure that will be correct. And again, I am following the discussion as a chair looking for consensus. Lawrence, I'm not sure you're correct there because I have seen disagreement on the list of when you're talking about this serialization, is this included or not? And therefore having test vectors for saying these all should turn into this in this serialization, but not in this one, might be useful. I could be reading it totally wrong, but that was my view, is that there are some disagreements on that level.
Yeah, I mean, there's a couple of points where I could see it going differently, but a lot of it is very similar. So,
and as Carson points out, we are using the term serialization in different ways, and therefore, having them nailed down would be really good. So, I mean, in the test vector side. So, Joe, you've got your hand up again.
Yeah, I'm all for having a longer list of test vectors than anybody thinks is really necessary. I find that, so I use my test vectors to ensure I've got 100% code coverage, and that often ends up with weird little edge cases. So I don't think we should be trying to produce a short list of test vectors. I think they should be comprehensive.
Sounds good. Thanks.
All right.
Then one other comment, going back to the appendices, whether they're normative or not. I had a pretty large goal to keep this draft very short. I was really hoping for the normative text to be under 10 pages. So that's one of the reasons a lot of the stuff is in appendices, is I don't think an implementer needs to read them. So I think there's some debate there.
You
Nothing.
might be able to finesse that, again, going back to the, one of them is to, when you tell readers who are not familiar with this, you really should be doing this one. You can say, and if you agree with this, you don't need to read those 2 sections on that one and the other one.
So my request is, Rohan, in particular, let's consider the appendices one at a time. The PR or the open issue is for 2 appendices. And then I think we probably have
2 PRs, check.
Yeah, and we probably need to discuss this on the list.
Oh yeah, absolutely. We need to discuss all of these on the list eventually. We might need to discuss these on the list before, we start slamming stuff in for the O2 draft.
Okay. And then my plan on an O2 draft is as soon as we've got enough changes to warrant a new draft, I'll publish it. So
Great,
I'm not,
thank you.
I don't want to wait for anything in particular. Just as soon as there's enough material to publish.
Great, thanks. Carry on.
Okay. All right. So now we're off to big numbers. Let's see. So I believe that the question at hand, what trying to get consensus on, is whether we retain the equivalence, big numbers and major types 0 and 1, or we change and don't have that equivalence. I'm interested in, I'm working towards a pretty solid consensus. This is why I'm surfacing this in lots of detail and trying to make sure there's lots of discussion and encouraging input from a lot of different people to know that we have a solid consensus, so we don't go back and discuss this thing again. So I'm kind of wearing 2 hats here. One hat is, I have an opinion about what it should be. The other is as, kind of more of an administrative authoring role where I am trying to create the consensus and then document it. So, understand how that works. This text I've highlighted here is, I believe, the key text that tells you that in all of CBOR, there is equivalence. There are no cases in CBOR of any sort that where there is not equivalence. I think this is a fairly difficult bit of text to interpret that way, but Karsten basically convinced me that that's the way it is to be interpreted. There's also other text in there that is very clear, is more clear that the equivalence exists for preferred serialization and for deterministic serialization. It's also clear that this is just for big numbers, not big floats and decimal fractions, because there's no such text like this for anything else. So I wanted to be clear about what text we're talking about here. I wrote a pretty long email about why I think this text can be interpreted this way or should be interpreted this way. I don't think it was very well understood, or I don't know if people read it or not or what, but I didn't get a good sense that there was a broad understanding of it. Karsten, I think, I don't want to do an academic discussion about equivalence here. So I think what I mean by, I don't have a good phrase. Maybe I'll come up with a better phrase, but the main thing I'm saying here is that when you are encoding a number, smaller than in 64 max, you can never encode that as a big number. You must encode that as a major type 0. That's basically what we're saying. Is there any other flavor of equivalence or something like that we need to, go ahead, Karsten.
Yeah, since you are asking me specifically, there are different kinds of effects that a statement like this has, and I actually have 4 slides on them. So I'm not going to say one sentence what the effect is, but I think it's really important when we make statements like this to distinguish the different players in a communication. So we know what the specific player is supposed to do, or how it is to interpret information or handle specific errors. So I think use equivalence or something like that is falling a bit short. So that's why I think we should look at this in a little bit more detail. So I think you are trying to
Wearing my chair hat, I will
say the right thing.
Yeah. Wearing my chair hat, I will say this is exactly like a great discussion for the mailing list. That is, trying to do it in slides here, especially where it's 4 slides that were at the end of an unrelated presentation, is not a great use of this. But given that we do have, as Karsten points out, different actors, so somebody saying, I'm creating this with equivalence is different than somebody saying, I'm interpreting this with equivalence. This is exactly the kind of detail that if we get written down in proposed text for the draft, that we can bang away on until we agree, if nothing else, that we agree on who the players are and what they are doing, and then go to what they want. Carson, since I cut you off, why don't you just hop in ahead of Rowan?
I was just asking to actually use my slides because it's not, as you say, it's not unrelated. It's exactly the question we're trying to solve.
I already removed your slides from this because I looked at the first couple and thought they weren't relevant. If you want to propose,
you have to look at the whole set because I don't know which of these slides I am going to need.
Okay. Well,
so
at
the
that
slides
point, then
18 to 21 are the ones that I would use now.
Okay, well, just resubmit and then we'll just focus on those. I removed it from the queue before I had gone all the way through to the end. Rowan, you've got your hand up?
Yeah. Specifically, I think one of the most problematic parts about this is that it's because support of any tag is optional. Somebody who doesn't support these 2 tags will treat this differently than somebody who does from an equivalence perspective. Like somebody who doesn't support them will have to treat them as not equivalent, while somebody who does support them has to treat them as equivalent. And that just strikes me as a very, very bad situation. And so my concrete proposal was, that we have perhaps new tags that are that have the same semantics, other than they do not have an equivalence with the major types 0 and 1. And so you could happily use those going forward. You would have to continue to use the, process the old types correctly according to the RFC, but we could actively discourage people from using them that wanted to use deterministic encoding. going forward.
Okay, I'd like to kind of get back here. I don't, Paul, I really don't expect to resolve anything here. I also think that the amount of text that is going back and forth on the list is so much that people can't read it. So that's one of the reasons I really want this kind of face-to-face discussion. And I mean, I think we write so much there that it's difficult. So I any alternatives we can make use of. And Paul, I actually just let's just go on with our discussion here, please.
Sure, absolutely. And if you want to take a break and have Karsten's 4 slides and such, we can do that as well. He turned them in and I can put them up if you want him to do his slides which cover this. That's up to you.
Okay, let's get through some of this here and see how this is the last slide I have. And I want to offer some framing. I think there's, a question of how do we interpret tags 2 and 3 and their equivalents. And that seems like a binary decision. Either we say they're equivalent or we say they are not. And that is like a binary decision we can come to on, and come to consensus on and have that established and done and closed out. I think you could even say that there is a, Rohan's proposal that there is new tags. I mean, that can be orthogonal to even that binary decision about equivalence. So I don't think this is a subtle, or I mean, I don't think this is a simple thing. It's pretty subtle to understand. And so I made a list of like pros and cons of like why I think there should be equivalence, or we should retain the equivalence or not. So I'm going to go through them and then can have discussion around them. So, I believe RFC 89 is, does require the equivalence. So yeah, I think the existing document says that, although I think there is wiggle room in there. We changed what we did for NAND payloads. So there is the possibility to change what we do here. I think it's a bigger deal than for NAND payloads, but so I do think 8949 says it requires equivalence, but I do think we could change. And I want to have the debate again so that the people that want the change, realize we have consensus and we're keeping it, and then we can put that discussion to rest. So next bullet is, a unified integer space is nice. It's pretty and kind of clean. A protocol can rely on the distinction between 2 types in the data model. Like, for example, EAT relies on whether the next data item is a map or a byte string or a text string to understand what submodule is. So when you merge the 2 data types in a protocol or in the data model, you take away a mechanism that protocol designers can rely on. I think they should not rely on this. I think, particularly this would be poor, but so that's a good reason to keep the equivalence. When I look at existing implementations, I looked at about 8 of them. I found varying support, but surprisingly more support than I would have expected for the equivalence and for big numbers. So I call that neutral. Same with implementation effort and API effort. I call that neutral. It can go either way. It's easy in environments that have big numbers built in, but it's not in environments that don't. And it's pretty difficult in environments that don't, depending on how far you want to go. Wolf has made some comments about how it's more difficult for determinism because I believe this is tweaking the data model. That was a debate we were having on the list. I don't think we got to the bottom of it, but I think Karsten says we're not tweaking the data model. I think we are. And that has implications for determinism, because you need determinism in the data model and in serialization. Then of all the things that we have in the serialization area, definite lengths, shortest length encoding, this is the one thing that is like a tweak to both the data model and a serialization requirement. I mean, that has caused me quite a lot of difficulty to make sense of. And it's resulted in the document being structured in a confusing way and hard to understand. So that's certainly a negative for me. And then people have talked about map key duplicate checking is more difficult, because you have to interpret this as, in the data model, not in the serialization. So that's my list of pros and cons, and trying in a kind of in a author, with my author hat on, I tried to make this list, to sort of help everybody, think about it, where the trade-offs are. This is an engineering decision. It's not a pure conceptual decision or anything like that. I think it's an engineering trade-off. From my personal point of view, I'm leaning to keeping the equivalence, even though this kind of nets out to zero if you kind of add up all the points here. So, okay, thank you for listening to that discussion. Please let the rest of you folks go ahead and discuss.
So Carson, is this an appropriate time for you to go through those 4 slides?
Indeed.
Okay, let me swap over to those. All slots are already taken.
Yeah, you have to take away slide control from Lawrence, then do your thing, and then hand me the slide control.
Right. Okay. I want to take it away from Lawrence.
A little bit more complicated than it could be.
I want to share slides. I want to confirm my selection. And wait a sec. Why did we end up? Yes. Okay. And then you
want
will
to go to slide 13. Yeah.
Yes. Okay. So I'm going to make it so that you can go to slide 13.
Or 18, actually.
Or 18, whichever. But
what is
yeah,
13?
One of the last 4.
No, really 18.
18.
Okay.
You are in control.
Yeah, thank you. So the important observation, and I think Rowan has said that, is that in CBOR tags are optional. So the implementation of tags is optional. So we have to work with a situation where the various components of the chain are at different statuses with respect to implementation of tags. And I put this little graphic here on the mailing list, ASCII graphic, where we have a producing application, a generic encoder, then the actual interchange process that is not doing anything but just transferring the data, the generic decoder, and the consuming application. And first of all, two observations. If the consumer, either the generic decoder or the consuming application, implements tag 2 and 3, we don't have an interoperability problem. So this is observation number 1. Number 2, if the producer never sends tag 2 and 3, we don't have an interoperability problem either. So we have to look at the situation where the producer sends tag 2, 3, and the consumer doesn't understand that. And that's going to be the rest of the slides. So
actually, before you go forwards, can you describe what doesn't understand that mean? Because one of the things I saw on the list where people were being confused was they know it's a tag, they know the tag is supposed to be over this kind of thing, but they don't treat it as necessarily as an integer or as an equivalent. So when you say that there is no problem, can you be specific about what there is no problem on?
Well, you just asked about what implements mean. So let's answer that question first. You can handle a tag in the basic generic data model or in the extended generic data model. And that's exactly the long form description of CBOR of RFC 8949 about what I simplified here as implementing a tag or not implementing a tag. If you are not implementing a tag and you are still a generic decoder, then you handle the tag as an opaque container for some tag content. And that creates a problem. If you do implement the extended generic data model, then you know that it's an integer and you can make decisions based on that fact. And this is really in practice rather Boolean. So there are a few cases where you might have gray areas here, but I'm willing to learn about where that might be the case. So right now I want to come from the hypothesis that if the consumer implements tag 2.3, there is no problem. Now, no problem doesn't mean it's becoming somehow easier to map integers to the platform data types. So for instance, in C, we just stop at some point. We might have 64-bit numbers, we might have 128-bit numbers, but at some point that stops. So you need something like a multiple precision library to support numbers that are even larger than that. But that's orthogonal to the question, do we have a serialization issue? And I want to focus on the serialization issue. Similar problem is with JavaScript, where we have a separate integer type that has a larger range than the integer support that is in the number type. And the separate integer type came later, so it's not integrated as well. And so it's another kind of hardness. And of course, we can't fix that here. We can only do things that are implementable for people who find themselves on these platforms. So let's talk about the situation where the consumer does not implement tag 2.3 and the producer does send them anyway. So how do we actually get there? So why would a producer send tag 2.3 when it doesn't know the consumer implements tag 2.3? So yeah, I have to read Juan's message now. Or do you want to say that?
No, you continue. It's a sidebar.
Yeah. So generally, again, we cannot solve the problem if the platform does not support a particular data type, and you don't want to implement it somehow in the generic decoder. That's not a solvable problem. So I'm not sure we should spend a lot of time on that. So if you have an application data model that uses 512-bit integers, and your platform, the platform of the implementation doesn't support that, then you are in trouble. So I think that's not a problem that can be solved. So let me just focus on the problem I try to isolate here. Okay, Juan.
Yeah, so you said if the consumer doesn't support what you want to send, then that's not a problem we can solve. But the problem that we could solve is we could solve detecting that the consumer doesn't understand it before it starts to receive a lot of data.
Well, this is a representation format, so I'm not even sure that I understand the word before. So the application data model tells you what application data to expect. And if there is something in there that you cannot handle. And the trivial case, the very usual case is you have an implementation in a constrained environment that doesn't do floating point, and somebody sends you floating point. You are up the creek without a pedal. You cannot do very much. And that's exactly the situation when somebody sends you numbers outside your range, and you cannot represent them on your platform. That's exactly the same situation.
Right, but in one case, like there are, for example, in COT, there was a decision to be able to represent time values either as integers or as floats. It's possible that you're happily receiving integers and all of a sudden you're receiving floats and you go, crap, I can't read this date. Okay. I generally think that, however, if you sent a value that was never is always a float and you sent it once, then the receiver is going to get that and it's going to know I can't read that because I don't do floats. And it's very likely that if you're sending the same data format repeatedly, that it's going to fail early. This is not the case when you have big int support and the big integers and the big integers have to be reduced via deterministic encoding down to major types 0 and 1. That you would find out very late. This is the kind of thing where you would find out, you might find out years later, oh, whoops, these two applications that I thought worked together, they don't actually work together because of this incompatibility.
Well, if you are using deterministic encoding, you don't have a problem. So I'm trying to understand what you are trying to say.
The problem is that you have two applications. You have a sender, and it is sending, and all of a sudden it starts to send, it's been sending major type 0 and 1. The consumer, the owner of the consumer thinks that the consumer is properly written, and all of a sudden it starts to receive major type 2 and 3 instead of major type 0 and 1, and it breaks. And it breaks years after it was deployed, instead of breaking immediately.
Yeah, how would that be different from suddenly sending float?
That's the thing. You don't suddenly send float in most cases.
Yeah.
You send float all the time or you don't send float all the time, except for this, the example of sending dates in COT, right? Which is another reason why I think that was a terrible idea. But, sending the same type, you should either send the same type or not send the same type. But if you suddenly change the type, if you can change the type in the middle based on the value, that's going to cause interoperability problems in the real world.
So I'd like to comment on that, Rohan.
Good.
If you have a protocol that's operating on major type 0, for years, then you're sending, 64-bit integers, and that's it. And presumably the protocol was designed to use only 64-bit integers, and it doesn't ever need to use integers larger than that. So
that's not what I'm saying, Lawrence. What I'm saying is that the designers on the sending side decided that they needed U128.
Okay.
But because of this decision that we're making here, they had to send that as a number that is major type 0 or 1. The receiver misimplemented it, and no one was really able to realize this until potentially years later. It wasn't obvious that this thing was going to switch types when it hit this range of greater than 2 to the 64th.
But that's the same thing with 32-bit integers and 64-bit integers.
Yeah, but this is like everybody. This is not a different major type. Everybody like all the libraries support this. All the operating systems, all of the programming languages support this. This is like switching from 32 to 64 is not a strange thing. But you know, as Lawrence said, particularly in languages like, you know, compiled languages, switching from 64 to 128, or certainly switching to going from using major type 01 to major type 23, or to tag 23, this is a big difference in what happens on the wire. It's a difference in what's required in terms of the libraries, of what's compiled. It could be even that this person, that the consumer actually thought that had support for tag 2 and 3, but it required a dynamic library that wasn't on the system, right? I mean, like that kind of thing can happen that you don't find out about it until later.
So, I would like, if you're using deterministic encoding, if the sender is using deterministic encoding, it's gonna be consistent. There's not gonna be any behavior change. So let's say you're sending a 100-bit big number. Well, then
but it's a counter. It starts off at 1 and increments slowly, and years later you hit.
Okay, that's just bad test. That's just bad testing. I mean, that should have been a test case.
But
right?
you're asking for that problem. Like we're inviting that problem specifically.
We have that problem. We have that problem all over the place already. You should
Joe
be
just
testing
mentioned
this.
the 2 to the 53 problem that we are all aware of.
Yeah,
which is the same thing again.
I'm not convinced.
So, Lawrence, I think this leads to at least an issue, which is signaling, and I don't know that we can answer it, but signaling between the producer and the consumer, if there is a way of doing it multiple ways. And we're talking about tag 2 and 3 here, but as Carson pointed out earlier, there are some other ones, with NANDs where this is. So I would say maybe toss that in the issue list. Maybe that goes in as a fuzzy statement in the document saying you might have problems going between some of these serial, or with people misunderstanding how far they have to do on serialization. But I don't think we need to deal with it now. And also Carson still has a few more slides.
Yeah, I think these will be quick. Lawrence, do you want to say something?
No, go ahead.
Okay. If the consumer does not implement tag 2.3, why would the producer send it? Now, again, you have to remember this is a document representation format. So we are not necessarily in an interactive session where we can have negotiation at the start and so on, but there are encoded data items sitting somewhere in a database, like in a transparency database. And somebody looks at those 5 years later. So the producer has to be cognizant of the consumers that will be using those data. So there is an application data model, and that either does not require tag 2.3 or it does. And depending on that, the situation would essentially be a bug in the producer or a bug in the consumer. And yes, Johan, I completely agree. We should catch those bugs. But I don't think we actually have a problem here. And now let me go through the other 2 slides quickly. So the computer. Again, with deterministic encoding, either the common one or the legacy one, the producer never sends tag 2 and 3 unless forced by a data item that is out of range for empty 01. So in deterministic encoding, we don't even have the problem. if the application data model allowed larger integers and somehow was not really intending to do that, that would be a bug. So yes, there is a little bit of onus here on the protocol developer, but the protocol developer is actually less concerned with tag 2.3 or MT01. The application developer probably is more concerned with platform types. And I think that's a pretty useful discussion we have been having in the last couple of weeks, that we have to be more helpful when defining our application data models, allowing platforms to come out with the platform types that are useful for them. Okay, so if we are not using deterministic encoding, then the producer can still address the fact that it doesn't know what the consumer supports by sending all integers in M201 if they fit, which also, by the way, is what preferred serialization does. So that is actually a takeaway. If we don't know about the consumer support of tags 2.3, we shouldn't send those tags, which maybe is trivial, but it's worth saying. So my redux of this is the problem I'm talking about is sending tag 2.3 serialization for data that are in the major type 01 range. Everything else is an application data validation issue and needs to be solved there. But that is fundamentally allowed in generic CBOR, in general CBOR, but it doesn't happen unless someone sets out to do it. So we probably need to say this is, like all use of tags, a special case. If you can use a tag to do something that you can do in a different way, then maybe you should think twice about using the tag, because if you don't know that your consumer is going to support it. And what Anders also pointed out is that there are considerations in the API design, and that's certainly something that an API designer should think about, not accidentally creating that special case. So sending a tag 2.3 only works reliably if tag 2.3 support by all consumers is known, or if it's totally okay for the consumer to fail, because we fail reliably here. If we get a tag that we cannot interpret, that's an error condition. So the application protocol needs to be examined. Does the data model include integers beyond major type 01, or is tag 2.3 support explicitly required by the application protocol, which, for instance, I would do for the 6-tish application. Yeah, maybe I'm repeating myself, but that's the job of a summary slide. Thank you.
Before you go away, so one thing from the previous slide that I want you to consider and then bring to the list. Are you suggesting here that if the serialization document discusses this as part of the data model, that therefore use of this should in fact be suggested as, if you're doing this, you really want to only be doing it with determinism so that you will fail, completely obviously? Are you suggesting that we add in another implementers should do determinism?
No, I don't think that is a requirement. I'm just saying that all arguments about determinism are moot because it's solved by determinism.
Okay.
But if you are not using determinism, then you have to avoid accidentally or surreptitiously sending tag 2.3 when that might confuse receivers that don't promise support.
Okay, I just wanted to check if you were pushing us towards determinism. Actually, and Lawrence, we've got 6 minutes left. Why don't you take over again? Do you want Karsten's slides? Do you want yours?
I'm just going to speak here. You could, if you could get back to my slides, would be nice, actually.
Yep. Okay.
So my takeaway from what we just had there was a discussion about interoperability and deployment of tag 2 and 3. And that was not an issue that I listed on my list of issues, but I think it could be added to that. Let's see here. No, I did the wrong thing. Oh, shoot. How do I get back to that? Change deck. There we go. So basically what I would do with the discussion we just had is add another bullet point at the bottom on deployment and interoperability of tag 2 and 3, and I would call it neutral. I don't think it's a big issue one way or the other in terms of the decision of whether we keep the equivalence or not. Because I don't think it makes a difference one way or the other. Okay, Karsten, yeah, go ahead.
Well, the whole point of writing a standard is getting interoperability. So I wouldn't want to have this as one of 9 items on a bullet list. So we really have to make sure that we get interoperability in those cases where it's possible. That's the overriding concern for me. And whether something is nice or poor, that can be discussed. I think these are still important observations, but we really have to make sure we understand the interoperability and give advice that makes sure that people don't make accidental mistakes destroying interoperability.
Yeah, I'm not saying interoperability is unimportant. I'm just saying the interoperability doesn't seem, I mean, to me, it doesn't seem like it's pushing the direction really hard one way or the other. I mean, there's an interoperability issue no matter how you frame it here. If you keep the equivalence or you don't keep the equivalence, there's interoperability on both sides. So I don't see it as anything pushing us one way or the other, so it's a neutral. So, I mean, the biggest thing for me is that, I think it's pretty clear that RC 89 does require this equivalence. That's probably the biggest factor in all of this, is that's what's understood, and what a lot of people have seen that implementation. So anyway, let me ask you, in general, anybody else have comments on any of these other pros and cons?
It's unfortunate that Wolf isn't here, but I think he articulated his position pretty clearly in his email of December 20th.
Yeah. Can you summarize that? Or?
Well, I mean, he says, if CBOR declares itself as adopting the extended model, then future extensions could render existing CBOR serializations invalid. 2 encoders separated in time or working with different versions of the extended model will not converge on the same serialization.
Yeah, I think that go ahead, Lawrence.
Yeah, I think that's in some negatives for determinism issue. That's what I intended to capture there. Yes.
Yeah, but as I said, the problem doesn't exist when you do deterministic encoding. So what Wolf found out is that CBOR is extensible, so you might have new tags, and those tags might come with some language about deterministic encoding, and existing implementations won't have that. But that's
Yeah.
not a problem.
No, I think that is a problem. Like, I mean, basically, like my whole example of tag 2 and 3 is we should not be mixing tags and non-tags. Like, unless we want to add like a crit, a crit field or some damn thing like that. But there should, having the model change what type you treat something as, that's really bad. That's not helpful for interoperability.
It's a serialization type, not the type that you actually treat it as.
I agree with you.
Whatever.
Rowan, I agree with you on that.
So we are at time. Lawrence, do you have enough from this to go back to the list and get some of these things, pick the hardest ones first for trying to get consensus? I'm not hearing you, Lawrence. Did we lose you? Well, bummer. Okay, so we are at time, and oh, Lawrence says his headset died. Well, appropriate timing there. Again, the purpose of this interim and any future interims is to try to move forwards on consensus. Hopefully, this last hour is helping Lawrence because, in fact, he is the one who's driving this at this point. The chairs are being mostly silent on consensus calls because we hope that the working group will work hard at getting consensus. That is, that we know that consensus is not always easy. And we only need to step in if there is a complete blocker. So, Lawrence, do please keep that going. Rowan, you signed up for some things. Joe, you signed up for some things that are a bit later. Hopefully other folks on the list will sign up for some things and we can move it forward. So thanks very much for attending.
Thank you.
Bye.